handling bodily waste triggers an automatic biological repulsion to keep the system away from pathogens. It's an evolved survival instinct preventing systemic contamination. But the material we instinctively avoid is actually a high-value health record. Every transaction made by your digestive workforce leaves a trace here, functioning as a daily ledger of your internal state. Digestion leaves behind an information-dense account of your metabolic and chemical activity. Think of it as a physical receipt for every biological trade your body made today. Refusing to audit this ledger means you are operating on guesswork. Without reading these receipts, there is no way to know if your internal workforce is managing your health portfolio effectively. Accounting errors like rising internal inflammation or dropping levels of protective fuels often compound in total silence. These shifts happen at the microscopic level, weakening the gut wall long before you feel any physical discomfort. Overcoming that initial sensory aversion is the first step toward professional-grade health management. It's the only way to get the baseline data needed to keep your internal system stable and resilient. Biological data is extremely fragile. The moment a sample leaves the protective environment of the body, the internal code begins to rapidly decay. Heat, oxygen, and light exposure act as immediate corruptors. If left unshielded, these environmental variables will break down the genetic information before it ever reaches a lab. To bypass the need for expensive cold chain shipping, modern kits use a specialized liquid stabilization buffer. This chemical shield instantly locks the biological code in place, freezing the microbial community so they don't change. The stabilization keeps the sample secure at room temperature, immune to external variables from hot delivery trucks to cold warehouses. By the time the laboratory opens the tube, the genetic material has experienced zero corruption. This protocol ensures the technicians receive a representative snapshot of your gut, one that matches your internal environment exactly as it was at the moment of collection. Proper stabilization transitions the process from a messy biological reality into a secure, professional data transfer. Once the asset is secured in the lab, the analysis narrows its focus to the specific ecosystem of the intestines. Scientists use a high-resolution metagenomic scan to read the raw DNA within the sample. This tool allows them to identify every microbe currently living in your system. The result is a full workforce roster, a map of your gut's organizational structure by species. It identifies beneficial microbes actively working to maintain your gut wall, while auditing for security breaches by flagging pathogens or genetic malware that signal future inflammation risks. By measuring the total variety of these microbes, we can estimate how resilient your system is. A highly diverse workforce is better equipped to handle dietary stress and keep your health portfolio stable. The metagenomic scan effectively translates biological waste into an actionable blueprint of your internal operations. It's a mistake to view the gut as a chaotic environment that resets every time you eat a different meal. Long-term research, including the Australian Breakthrough Cancer Study, has followed thousands of people to see how these internal ecosystems actually behave over time. This chart shows gut ecological stability. Instead of daily spikes, data reveals a near-flat trajectory. The microbial workforce remains stable for 6 months. Therefore, a single scan establishes a pristine baseline, acting as your primary anchor point for future tracking. Rather than waiting for a crisis and reacting to symptoms, this data allows you to manage your health as a proactive portfolio. Securing this information requires navigating a brief moment of logistical friction, but the result is a clear, predictive window into your internal health. It's the difference between flying blind and having a reliable map of your own biology.